Welcome to Astron series, People of Space. I'm your host, Shweta Kulkarni, and through this series, I am chatting with some amazing people working in the space or astronomy industry.
Inspire the world, a brand new face. Welcome to the people of space.
So today, I will be chatting with Alejandra, who is a dear friend that I met in space camp long time ago, and she's currently doing her PhD about neutron stars. But get this, she's at this dreamiest observatory at La Palma right now, where I desperately plan to visit her. So I'm very happy to have you on this podcast, Ali. Welcome.
Thank you for having me, Shweta. It's a pleasure to be here.
So before we get into your professional journey, tell me this. If your life as an astronomer was a space mission, what would you call it and why?
So this is a hard question. I would say maybe I would call it chameleon. Because my career so far has been quite non-linear. There's been a lot of changes, and I have tried to adapt, changing different fields and so on, different research topics, different research methods. So that would be my answer, I think.
That is so cool. Of course, like I was also going through your career background and everything, and like you have a lot of jumps in your career, and I have been like
Yeah.
tracking that throughout the years since the camp. But I think for me, the coolest thing is your work at the observatory at La Palma. I mean, working as a telescope operator, I bet you see like some amazing celestial sights also. So, can you tell us like one unexpected part of operating the Nordic Optical Telescope that people might not guess?
So I would say actually that the one of the most surprising things is not only what you see up in the sky, but all the weird natural phenomena of our own Earth you get to see on the telescope. For example, so we are like in a the altitude of the Roque Observatory is like 2,400 meters. So if there's a storm, you're inside the cloud actually, and you start getting horizontal rain in your face, which I had never experienced before, and all sort of weird phenomena. I also saw the start of a forest fire. I was up observing, and I saw on the webcam suddenly like orange pop up, and I was like, that's really strange. And it turns out, like, when it was morning, we saw the smoke coming out of the fire. Like, you get to see front row, a lot of weird phenomena, I would say. I saw the aurora, the last time I was up a few days
Yeah,
ago, which is insane. We're so near the equator. We got to see the aurora as well. So yeah, I would say, like, our own Earth is the most shocking thing in that sense.
that's crazy. Yeah, like I was looking at your pictures of auroras on Instagram, and I was like, wow, they're coming. Like they're visible from such lower altitudes also. Like that's crazy. Must
Yeah.
be beautiful. But you have been most involved in the stars throughout your career, right? So like you must have done various fascinating projects from thermonuclear bursts to neutron stars and to studying star forming regions. So if you could pick just one to be your astronomical legacy, which one would it be and why?
This is also a really hard question, because I feel that in science, you can make really good science and not get very flashy, very clear results. So I am proud of all the work I've done. But interestingly enough, I would say the most clear, pretty results I got was when I worked with star forming regions, actually. This was an internship I did with ESA some years ago, and it was very nice because I was looking at a globular cluster, the chameleon cluster actually. I just remembered. And I was looking. So globular clusters, the stars all have the same age, and I was trying to look for stars that clearly belonged to that region but were older. Because that would tell you that that's how the cluster evolved throughout time and how it moved. And it was very pretty when I finished that project because you see that older population, and it was just clearly to the left of where the region was. So you could clearly see how the stars have moved direction, and it was very satisfying to get that result. So I guess that would be my answer actually.
Yeah, I mean, you've been working with like lot of stars, right? So like with this cluster and everything, it sounds so intense, like especially the X-ray emissions of like neutron stars. Like I'm having tough time having my head wrapped around it, like what exactly like it is. And maybe like you can tell us about it with a little bit of twist rather than giving like just general answers. I'm not trying to ask you hard questions, okay? I'm just trying to ask you weird questions that maybe nobody have asked, and people can learn something new about this rather than just, normal professional astronomical stuff. So tell me, like, what's been the most surprising or challenging discovery you've encountered during your doctoral research? I believe you're doing your research in Finland.
Yes, yes, correct. Um, yeah, so my thesis is I do X-ray astronomy on neutron stars, right? Um, and I would say actually the the thing is X-ray astronomy is quite different from, for example, optical astronomy.
Yeah,
And so in optical astronomy, obviously you have a lot of data, you have a lot of photons coming in. And for example, when you look at a spectrum in the optical range, you know exactly like if you have this spectra, it's because you have this phenomena happening because the data is very clear. But in X-ray astronomy, we have like five photons coming in, and we have to make do with that, right? And that means that when you get a spectra, for example, there's a million different ways you could get that spectra that make numerical sense. So it's a bigger challenge to actually understand what is going on when you get that X-ray information. And precisely so that's what I work on. I try to test different models to see what is going on in the neutron star when I get that X-ray data. And the shocking thing for me was precisely this. You have models, for example, that work. I work with very quick explosions, and what I found was models that fit for the very first 10 seconds, and they don't, or vice versa. And that's bizarre, right? Like, why would it work for so short? What is happening inside the neutron star for that to happen? And all of this part, I would say, is the most challenging of my research, definitely. So yeah, that would be my answer, I think.
that is like such a deep astronomical stuff that you just told us. So, but you also like you love doing science communication, and like if this was like a science communication, focused podcast, you would explain it like in an easier way, kind of. But like our audience is mixed. I'm sure people would like love to get into some, technical stuff also. That was great. But talking about science communication, you worked with the International Astronomical Union's Office of Astronomy Development also. So maybe you can share about your work over there, your like memorable insight from that project that might change how people think about space science and sustainable development.
So I would say, and I always say this when I talk about my work at the OED, the Office of Astronomy for Development, that I was really shocked to realize how many sustainable development goals you could actually use astronomy for. Because when I got into this project, I assumed, sure, like astronomy will probably help with education, for example, right? Which is the main focus, and it does amazing work in education. But I was very shocked to see projects because what I did was analyze the impact of different projects. So I got to see really the timeline of all the projects that were funded throughout the years. And I was very shocked to see how astronomy could help the most in the most creative ways. For example, there has been a lot of projects of astronomy for mental health, which I find amazing that is even possible. And they got measured results in different populations, like kids, adults, all sort of people, refugees, and they really saw that astronomy improved their mental health. And I also got to interview, for example, a project that was about preserving cultural traditions from different groups in Chile throughout astronomy. And they told us how really like they managed to get the younger generations to remember their culture throughout astronomy, throughout this project. Oh, so I would say what the takeaway is astronomy is such a special field. It is very inspiring. And we have to harness that because it really can affect so many different ways in the world.
Yeah, absolutely. I mean, when you're talking about like using astronomy for mental health, it doesn't really seem connected. But, even with me, it was the case that when I started learning about the universe and how big this universe is, and I started realizing how small we are, a lot of things, in my brain kind of changed. And I gained like this different perspective towards life. And like, it's like two ways to say it that nothing I do matters or nothing I do matters. So I can do like everything and go crazy. And I like plan to stick with the second one, try to do everything and, try to do as much as I can. But like with your story and everything, do you even have like time through this hectic work to follow your hobbies? What are your hobbies? And like if you have time or like if you have these hobbies, tell them to us and also let us know how your hobbies can also help your help your work influence your work, help balance it.
So so as a PhD student, it's hard to find time for yourself, definitely. Especially now because I work part-time at the telescope and part-time as a research student. But I do try to carve in time for my hobbies because if not, I would go insane, I think. Um, and I always tell people this story, but when I applied to university, my first option was physics, but my second option was Spanish literature. And my third option was art school. So if I didn't get into physics, I would go into the arts completely. And I love drawing, I love reading, I love creative writing. I'm a very bohemian person. And I think it's healthy actually for scientists to have hobbies that are not related to science. It's good to develop that other side of our brain. So I really find it necessary to carve out some time for that creative aspect. And I would say it also it even helps my work in the end because even like if I want to do outreach, if I want to do a poster or a presentation, having skills regarding like artistic presentation, writing and understanding work concisely it does help. Curiously, I just submitted my first research paper. Um, and the one thing the people always said that was that the writing was very clear. And I was like, thank you. I made the effort.
Yeah, of course. I mean,
So
if
yeah.
you have this creative side, you are able to incorporate it into astronomy also.
Yeah. It is very fortunate to be able to sort of incorporate the more creative part. And I would say a lot of astronomers I know, they're also very artistic. I think it draws that kind of people into the field.
Yeah, of course. I can absolutely relate to that. Like, I'm also quite artistic and bohemian, a little bit hippie, and I love to like incorporate all that into my work also. That's why like this podcast is also there so that people can understand that, you know, these scientific people, the researchers, the professors, the, people who are actually working in the field, are making their careers in the field, they're relatable, because I was told when I was a little kid that, Shweta, you're good at arts, you're not really good at, maths or physics. And so you shouldn't choose it. But then I didn't know about this career option of being a science communicator. And as I got lucky meeting people like you along the way, with whom I could relate to and talk to about this and build my career as it fit me. Like, that's really inspiring. And I think just like me, astronomy is your passion also. So, like, when you have your passion as a career, like, that's really something else. And, but like, apart from this, how do you recharge? when you're not analyzing data for your research, or when you're not operating your telescope?
So it's important to find that time to relax, definitely. Because especially the telescope is very tiring work. It's I don't have to do it much. It's like 4 nights per month, but it's really exhausting. So usually, aside from the hobbies I just mentioned, I like to do some yoga in the mornings because physical exercise is important, but also yoga especially feels really good after being like cramped in your office or in the telescope. I feel I really need a stretch after all of that. It feels really good. Um, and then I would say, which is like a very classic answer, but it's true. I socialize with my friends and family, especially in the telescope is very lonely work. You're up alone in the mountain. You're on your own on the telescope for a few days, zero contact with civilization, basically. So when I come down, it's like I need to see everyone. I need to talk to people, and also with the thesis as well, right? A PhD is it's also a lonely work. And you have a lot of disappointments along the way. It's ups and downs, and you need to keep talking to people to sort of keep your head on the ground, and not go sort of crazy, right? So yeah, that would be my answer, I think.
Yeah, I mean, it's very true. Like after you're, going through such a technical analyzing through your head, and you're alone at the observatory on the mountain for a while, socializing and like meeting people is really important. And I know, at least like I think it's true for both of us, that when we meet people, we also like to ask a lot of questions and like kind of enter into their world and understand what they are doing. And that is very recharging. So imagine you're like back from your observatory after spending like 4 straight nights over there, and you're just like having a tea or a coffee with some historical astronomer or physicist. Who would it be, and what would be one question that you would ask them?
This is hard, because
It
I'm
could be
sorry
dead
saying
or
all the
alive.
questions are
Okay,
hard. Ah,
it
dead or
doesn't have
alive.
to be historic. You can tell even a live one right now. Apart from me, I know we would love to have some coffee together sometime soon, but yeah.
Exactly, exactly. So I would say maybe historic for a historical astronomer. Well, this is sort of cheating because she was a mathematician actually. But Emmy Noether, sorry. She although she was like a mathematician, her theorem, Noether's theorem was like one of the biggest theories in physics. It was revolutionary. And she was really interesting. She struggled a lot. As a woman first to be a professor in a university, but later on as a Jew in Nazi Germany. So like her life story, I would love to talk to her. She must be so interesting.
But could you choose
And I
like
get
one question to ask
yeah,
her?
if I had to ask one question, it's like, why didn't you give up? Uh, like you had so many things stacked up against you. Like why did you keep going in
Yeah,
physics? I would
absolutely.
say.
Wow. That that would be a good question to ask a lot of people, right?
Yeah, yeah, I would ask that to so many people.
Okay, now let's jump to future from the history and past. Let's like fast forward 10 years, and let's say you're stationed at a lunar observatory, and you're handling the telescope on either moon, or like, why are we stuck on moon? Let's go to like somewhere outside of our solar system, maybe not just 10 years, maybe like couple of 100 years. We are still alive, and we can work in an observatory that's in some other solar system, still in the Milky Way though. Let's not get too far away. But beside essentials, what can you bring with you? Tell me like 3 items that you would pack with you.
So if they still exist, I would get my ebook so I can read uh on this faraway lands. Maybe my yoga mat if the gravity allows me to do yoga, it might be really fun to have. Especially on the moon, for example, that would be great. Like you could do some nice acrobatics in doing your yoga. And maybe my drawing notebook, if that still exists as well, so I can paint out the landscapes there.
That sounds so cool and like very similar to like the kind of things I would say. Yeah, that's interesting. Now, because like you're thinking more creative and a little bit like that, let me throw in a little bit of rapid fire round over here for you before I ask
Okay.
a couple of more questions. Okay? Don't think too much, just first thing that comes to your mind. All right?
Okay.
Favorite constellation.
I would say Ursa Major
Okay.
because
You can't.
it's the easiest one to see. I get it's like it's there. It's always there for me.
Wait, but you visited Africa and you also saw like some southern constellations also. None of them you
But
enjoyed?
it was very, very cloudy. I didn't manage. I was very sad about it.
Oh no. I'm excited to see the Milky Way from New Zealand.
Oh my God, yeah. That has
Mhm.
to be amazing.
Yeah. Okay, cool. Next one. If you could witness one cosmic event, past or future, what would it be?
Uh, the explosion of beetles, the
Mm,
supernova. It has. I hope it happens in our
yeah.
lifetime.
Oh, definitely. I am sure it's gonna happen. If we're that
Because of
lucky, we
this.
can also be somewhere in the dark skies away from the light pollution and
Yeah.
enjoy it. Yeah, I'm really looking forward to that also. Yep. Okay, so are you a night owl or early riser?
So this is funny because I'm an astronomer, but I'm not a night owl at all. Um, I wouldn't say also I'm a very early riser. I follow I have energy when I have sunlight,
Hmm.
basically, which
Yeah,
is a
that's
very
really true.
interesting
Yeah,
choice for
yeah.
an astronomer.
Absolutely, because but I think like there's a lot of misunderstanding out there about this that like when you choose a career as an astronomer, you have to like work through the night to observe the stars. And for you, like it's partly true because you work at an observatory, but like a lot of data analysis, like in astronomy, happens through the
Yeah,
day. So like
yeah,
let's burn
definitely.
that myth that you don't have
Yeah.
to be a night owl if you want to be an astronomer. There's a lot of things you can do in the morning. And yeah, like I used to also organize overnight stargazing events, but now I'm like, yeah, I want to capture that comet in the sky. Okay, it's gonna be visible in the evening. Let me know then.
Definitely. I'm the same way.
Okay, cool. Next one. Tell me in one word, what is space to you?
Art, I would say.
Hmm, I like it. I like it. That's interesting. Okay. Which one's more thrilling? The feeling of analyzing fresh telescope data or helping students discover the stars in the universe?
I would say helping students. I find that very nice.
Yeah, of course, the interactions, the
Yeah, the
curiosity, like,
human. Yeah.
yeah, that gets one going for sure. Yeah. All right, but like if you could change one aspect of how we approach space observation or research, what would it be and why? And I know this is not like a rapid fire question anymore. Like you can just, yeah, let us know what you think.
I would say one of the biggest problems right now in research is that we are really pressured to pump out papers really fast because that is what gives us funding, basically. And at some point, you stop caring about the quality of the research and just like put out papers as fast as possible. So I would definitely want to change that in the field, um, that we don't depend on that, basically.
Yeah, I think with AI, that change is like coming very soon, and I'm actually excited to see how the world change and how like astronomers change with it and what all we get to do, what becomes faster, what becomes slower, what becomes more interesting, and all that, and how art and astronomy can also like, get together with
Yeah.
AI and stuff. So yeah, definitely. But like looking at where we are now, what excites you most about like the next decade in space exploration? And maybe like after explaining that, give us like a message for the people who'd like to pursue a career like yours in astronomy and space science.
Okay, so I would say what in this upcoming decade, I think what's called multi-messenger astronomy is really exciting. So multi-messenger astronomy is basically looking not only at the light, which is what astronomy has done for of years, but also look at gravitational waves, neutrinos, see light in all its wavelengths of one single event. You look at it from different angles. And we're at a point that hasn't been possible before where we can do this really well. And I think that will give us amazing results in the next decade. Um, and if I had to give advice to people that want to get into the field, I would say, that's an interesting question. First of all, you should learn how to code, is what I would say. Um, because things, you have to be really flexible as well. Things can change a lot. But I think if you're willing to engage with different topics and you know some programming, you're gonna succeed, would be what I would say.
Yeah,
So like be flexible and learn to code. And then you're good
that's
to
true.
go.
I think it's very helpful because I think what all you told us goes along with like the same lines that we have been discussing in these episodes, that one should learn problem solving, and be
Yes.
it like through coding or like just with your thought process. I think that's one of the most important things that everybody who's listening to this should understand. But yeah, now Alejandra, tell us how these people who are listening to us on Spotify or listening or like hearing us or seeing us on YouTube, um, how would they reach out to you if they have any questions? Can they follow you on your social media? Tell us about your research paper, where they can find it, and maybe we can also put all these links in the description. But yeah, tell us
Yeah,
how they
yeah,
can
yeah.
connect.
So you can follow me on Instagram. But my name is hard to explain with. Maybe it's better to put the links uh down below, whatever. But it's like Ale Diaz T on Instagram. I also have a LinkedIn. My full name is Alejandra Diaz Teodori. Or if you want to look for it. I don't know. Well, my paper, it will be out soon. It's not out yet, but it will be published in Astronomy and Astrophysics under my name. Um, so I will let you know when that happens. And I think that's about it that I
Yeah.
would say.
Okay, cool. I'm really looking forward to your paper and reading it, and it's gonna be exciting. But thank you so much for coming on this podcast, People of Space, where we try to bring people closer to the people who are actually working in the field of space so that they don't feel intimidated to choose this career. And I hope people are enjoying it because this was just our second episode. And on this podcast, in these episodes, I am bringing people that I have come across throughout the years of being science communicator and talking to them, just like I would in general in a normal setting, and trying to bring these conversations to people so that they think or they feel that you guys are accessible, people who are already working in the field. So, everybody who's listening, who's viewing, stay tuned as we bring you more and more such interesting people of space. And if you have any suggestions for us whom I should talk to, let me know in the comments and we will try to get in touch with them. Thanks and cheers, guys.